So in this lesson, we are taking the chain rule and we're combining it with either the product rule or the quotient rule. So again, we want to be able to find the derivative of complex functions using these rules that we've listed already. And we want to be able to factor and simplify the resulting expressions that we get. Okay? And that's where that factoring work that we did back in the previous lesson is going to come in really handy. So let's just jump in here with an example. Okay? Our first function here, f of x equals x cubed times 3x minus 5 all squared. If we've got these two things multiplied together, we know right away that we are going to have to use the product rule here. We've got one function right here, x cubed. We've got another function over here, 3x minus 5 all squared. So our product rule was we thought of this as u, and we thought of this as v, and we know that our derivative, f primed at x, is going to be u primed times v plus uv primed. So let's, for this example here, let's sort of actually just break this apart. We'll say u equals x cubed, v equals 3x minus 5 all squared. So to find our derivative, we definitely need the derivatives of both u and v. So the derivative of u is pretty straightforward. This is just a power rule. We bring down the 3, we get 3x squared. What do we notice when we come to do the derivative of v? Well, v is a composite function. So we've got to use this chain rule that we've just been talking about. So when we do the derivative of v, we want to break it up into an inner function and an outer function. Our inner function is this 3x minus 5 on the inside. Our outer function is this something to the exponent of 2. So to do our derivative, we're going to bring down that 2, keep everything inside that bracket exactly the same, so it's still going to be 3x minus 5. Our exponent is going to be 2 minus 1, so it's now just 1. And we have to multiply then by the derivative of that thing that is inside the bracket. So the derivative of 3x minus 5 is just 3. So we've got our individual derivatives here, and I guess I could simplify this. This is 6 times 3x minus 5. Okay. So now we want to take these individual derivatives and put them into our product rule. So let's put this together. F primed at x is going to be, let's see, u primed, which is 3x squared, times v, which is still 3x minus 5 squared, plus, what's next? U, which is 3x squared. No, sorry, you're right, that's the derivative. I want x cubed, right, the original u. And I want to multiply that by the derivative of v, so 6 times 3x minus 5. And voila, there's our derivative. Now, we want to factor this. So this is going to be that binomial factoring that we did back in the lesson for part B. Think of this as being divided into two terms here at that plus sign. Okay? We want to look for things that are common to this term and this term. So what can we factor out here? Well, let's start by looking for constants. We've got a 3 in our first term, we've got a 6 in our second term, so we can factor out a 3. We've got an x squared in our first term, we've got an x cubed in our second term, so we can factor out the lowest power of x, which is going to be x squared. Then we've got 3x minus 5, which is common to both terms. We want to factor out, again, the lowest power of 3x minus 5 that we see. So that's going to be 3x minus 5 to the power of 1. And we're going to have these big square brackets. And we're going to have two terms inside these square brackets. Okay? Everything that started off in the, well, what's left over after we've done the factoring from the first term goes in front of the plus sign. What's left over after we do the factoring from the second term goes behind the plus sign. So for the first term here, we have factored out the 3, the x squared, and one of our 3x minus 5s. So we're going to be left with a 3x minus 5. From our second term, we factored out, well, from the 6, we have factored out a 3. So we're going to be left with a 2. Okay, 2 times 3 gives us 6. From the x cubed, we factored out x squared. So we're going to be left with an x. And the 3x minus 5, oh, we factored out the entire 3x minus 5. So we're done with the factoring. And if we look inside those square brackets now, we can simplify this a little bit by collecting our like terms. We've got a 3x and we've got a 2x. So this part out front that we factored is going to stay the same, 3x squared times 3x minus 5. But this thing in square brackets can be simplified to 5x minus 5. But once we've done that, we can see that we can actually factor a little bit more because we've got a 5 that is common to both of these. So if I factor out that 5, that'll give me a 15 out front. So I'll have 15x squared, 3x minus 5, and then x minus 1. Okay? And that would be my final answer. Now, what is the point of doing all of this factoring? Well, one of the common things that you're asked to do after you've found a derivative is to take your derivative, well, okay, you've taken the derivative, you're asked to set it equal to 0 and solve for x. If you're going to solve for x, you want to factor it. So you want it in factored form in order to be able to solve for x. Okay. All right. Are we okay with this? All right, let's try another one here. F at x equals 4x plus 2 cubed times the cube root of 6x minus 7. So if we're looking at this function, the first thing we want to do is we want to rewrite this to make it a little bit easier to understand what's going on. So we're going to keep the 4x plus 2 to the power of 3 the same, and we're going to multiply it by 6x minus 7 to the exponent 1/3. So just rewriting that cube root as the exponent 1/3. And looking at this, we can see that we've got two functions multiplied together. So we've got u and we've got v for our product rule, but both u and v are composite functions. So we're going to have to use the chain rule to get u primed and v primed. So let's just, in here in red, let's just write down what u primed and v primed are going to be. What is u primed going to be if we apply the chain rule? Nicole. Right. Okay, we bring down the 3, subtract 1 from our exponent, keep what's inside the bracket exactly the same, and then multiply by the derivative of what's inside. Derivative of 4x plus 2 is just 4. What about our derivative v primed here? What are we going to get when we do that derivative? All right, I'll take this one. We're going to bring down the 1/3. We're going to keep the 6x minus 7 in brackets exactly the same. And we're going to subtract 1 from our exponent. So 1/3 minus 3/3 is negative 2/3. And then we have to multiply by the derivative of that inner function. The derivative of 6x minus 7 is just going to be 6. So now, let's put this together to get the derivative of our original function. Let's get f primed at x. So we know product rule is going to be u primed times v. So u primed is 12, 4x plus 2 all squared. Okay, just combining the 3 and the 4. That gets multiplied by 6x minus 7 to the 1/3 plus, what do we need next? We need u times v primed. So u is just going to be 4x plus 2. V primed is the 1/3 times the 6 is going to be 2. 6x minus 7 to the negative 2/3. And that's our derivative. Now we need to factor. So we look for things that are common, and my two terms right now are broken up onto two different lines, but we always want to visualize this as being split up at that plus sign. We look for things that are common to the first term and the second term. So,
The cube after 4x plus 2.
what did I forget? Sorry?
There's the original function is square plus 2.
Right there. Okay. You're right. Thank you. And that's actually one of the most common mistakes that people make, is just forgetting those exponents there. Okay? So thank you. So 4x plus 2 cubed. So we're factoring. We're looking for things that are common. So if we look at the constant terms, we've got a 12 and a 2. So we can factor out a 2 from both of those. We've got a 4x plus 2 that is common. So we can factor out the lowest power of that binomial, 4x plus 2 squared. And 6x minus 7 is common to both of them. Again, we want to factor out the lowest power that we see, which is going to be 6x minus 7 to the negative 2/3. And then we'll give ourselves some square brackets here, plus sign in the middle. And again, everything that comes from that first term, or that's left over from that first term, is going to go in front of that plus sign. And everything that's left over from the second term is going to go after it. So what's left over from that first term? Well, we factored a 2 out of 12, so we're going to have a 6. And we've already dealt with the 4x plus 2. So what's going to be left is 6x minus 7 to the 1/3 divided by the term that we factored out, 6x minus 7 to the negative 2/3. So let's see, 1/3 minus negative 2/3 gives us 3/3, which is just 1. So we'll have 6x minus 7. In our second term, we have 4x, we've already factored out the 2, so 4x plus 2 cubed, we factored out 4x plus 2 squared, so we're going to be left with 4x plus 2, and we've already factored out the 6x minus 7 to the negative 2/3. So now we just need to simplify what is down inside those square brackets. So 2 times 4x plus 2 squared. Okay, I'm going to move the 6x minus 7 to the negative 2/3 down into the denominator. Okay, you don't have to do that at this stage, but I'm just trying to save myself a little bit of space here. So in these square brackets, we want to expand and simplify. So 6 times 6x is 36x. 6 times negative 7 is negative 42. And we add a plus 4x plus 2. So when we simplify, all of this other stuff has to stay exactly the same. Inside these square brackets, we have 40x, negative 42 plus 2 gives me negative 40. And this term down in the denominator becomes 6x minus 7, let's see, squared, and then to the cube root. And finally, it looks like I can factor out 40 from that second term in the numerator. So if I do that, I'll have 80 4x plus 2 squared x minus 1 all divided by the cube root of 6x minus 7 squared. So having it in this factor form makes it really easy to solve. I can see here that the roots of this equation are going to be x equals 1 and x equals negative 2, just by looking at it. Okay, we'll do one last example here, and then we'll be done. We've done product rule. What about quotient rule? You should be able to combine the chain rule with both the product rule and the quotient rule. I think, though, if you see a question like this, you should cheat. And you should not use the quotient rule. Okay? Because we can take this term, like in the denominator, x minus 2 cubed, and we can make that exponent negative and move it up into the numerator. So we can rewrite our function as 2x minus 1 squared times x minus 2 to the negative 3. So we've turned our quotient rule question into a product rule question. And we're really good at using the product rule because we've just done it twice. Okay, so let's just keep using the quotient rule. Now, there are going to be some cases where you might actually have to use the quotient rule or it'll be easy. But I think most of the time, if you see something like this, hey, just use the product rule. So we know we have got u and v for our product rule. Each of u and v are going to be composite functions, so we have to use the chain rule for both of them. But we're so good at this by now that we can just jump right to our derivative. Derivative of u, bring down the 2, keep the inside the same, subtract 1 from the exponent, multiply by the derivative of what's inside. So we get 2 times 2x minus 1 times 2. This has to get multiplied by our original function v, x minus 2 to the negative 3. To this, we are going to add our original function u, 2x minus 1 squared, times the derivative of v. So derivative of v, using the chain rule, we're going to bring down that negative 3. Keep what's inside exactly the same, x minus 2. Subtract 1 from our exponent. It's a negative exponent, so when we subtract 1, we get negative 4. And then multiply by the derivative of what's inside. Well, the derivative of x minus 2 is just 1. Okay. And now, so we'll just kind of label this. This is u primed v. This is u, and this is v primed. Okay, so now we can start thinking about how we're going to factor this. Let's see, the 2 and the 2 give us a 4. Our coefficient on the other one is going to be a negative 3, so there's no factoring there. We have a 2x minus 1 that's common to both of them, so we can factor out the lowest power of 2x minus 1, which is just 2x minus 1 to the 1. And then we can factor out the lowest power of x minus 2. Well, we've got an x minus 2 to the negative 3, x minus 2 to the negative 4. So we're going to factor out x minus 2 to the negative 4 because that's the lowest power. What are we left with? The 2 and the 2 give us a 4. We've taken care of the 2x minus 1 from the first term. So we're left with, let's see, x minus 2 to the negative 3 divided by x minus 2 to the negative 4 is going to give us just x minus 2. The coefficient in our second term is negative 3. We have factored out one of the 2x minus 1s, so we're going to be left with a 2x minus 1. And we've already taken care of the x minus 2 to the negative 4. So from here, it's just expand, simplify, collect our like terms. So we're going to be left with 2x minus 1. Let's see. 4x minus 6x gives us negative 2x. Negative 8 plus 3 is negative 5. And down on the bottom, x minus 2 to the power of 4. And that's as good as we can get. So, if you can, cheat when you're using the quotient rule and change it into the product rule.